Welcome to today's video, where we'll dive into the fascinating world of the sun and stars. Although they appear as tiny lights in the sky, stars are massive spherical objects that produce light and energy. Today, we'll focus on our sun, how it works and creates energy, and then explore the life cycle of stars from their birth to their death, including spectacular phenomena like supernovae and the formation of black holes. Let's get started. How does the sun work? The sun is the key source of life on Earth. It provides us with heat, light, and energy, making life possible. But how does the sun actually work? The sun is a giant ball of hot plasma, with nuclear fusion occurring at its core. This process is the source of its incredible energy. In the sun's core, hydrogen atoms fuse together to form helium. When four hydrogen atoms fuse into one helium atom, a tremendous amount of energy is released in the form of light and heat. Fusion happens under extreme pressure and temperature, which reaches more than 15 million degrees Celsius. These conditions are necessary for hydrogen nuclei to overcome their repulsive forces and merge into helium. Layers of the sun. The sun consists of several layers, each playing a vital role in producing and distributing energy. 1. Core. This is the heart of the sun, where nuclear fusion occurs, generating energy. 2. Radiative zone. Energy travels through this layer in the form of radiation. Photons, or light particles, move very slowly here as they constantly collide with other particles. 3. Convective zone. In this layer, energy moves through convection, where hot plasma rises and cool plasma sinks. This is similar to how boiling water circulates in a pot. 4. Photosphere. This is the visible surface of the sun, where sunlight is formed and emitted to Earth. 5. Chromosphere. Located above the photosphere, this thin layer is where the temperature starts to increase again. It's visible during a solar eclipse as a reddish rim around the sun. 6. Corona. The outer atmosphere of the sun, which is surprisingly much hotter than the surface itself. The corona can only be seen during a total solar eclipse and extends far out into space. How does the sun produce energy? As mentioned, the sun produces energy through nuclear fusion. In this process, a small amount of mass is converted into a vast amount of energy, as described by Einstein's famous equation equals mc, where E is energy, m is mass, and c is the speed of light. This energy then travels from the sun's core through the radiative and convective zones, eventually reaching the surface and being emitted as light and heat. This journey can take thousands of years. The energy we see today was created deep in the sun long ago. The life cycle of stars. Just like living organisms, stars go through different life stages. Their birth, life, and death depend on their size and mass. Let's break down this life cycle step by step. 1. Birth of stars. Stars are born in vast clouds of gas and dust called nebulae. These nebulae are primarily composed of hydrogen, the key building block of stars. When enough material accumulates in a region of the nebula, gravity starts to compress it, forming a dense core. This compression increases the temperature and pressure at the center of the forming star until it becomes hot enough to ignite nuclear fusion. At this point, the star begins to shine, marking its birth. 2. The life of a star. Once a star stabilizes, it enters the longest phase of its life, called the main sequence. During this phase, the star burns hydrogen in its core, converting it into helium and continuously radiating energy. Our sun is currently in this phase and has been for about 4.6 billion years, with around 5 billion years left to go. The length of the main sequence phase depends on the star's mass. More massive stars burn their fuel more quickly and have shorter lifespans, while smaller stars, such as red dwarfs, can live for billions or even trillions of years. 3. Death of a star. When a star exhausts all the hydrogen in its core, it moves into the final phase of its life. The fate of a star depends on its size. Small and medium-sized stars, like our sun, will expand into red giants once they run out of hydrogen. Eventually, they shed their outer layers, leaving behind a hot core that becomes a white dwarf. This white dwarf will gradually cool down and turn into a black dwarf, a cold, inactive object that no longer emits light. Massive stars experience a much more dramatic end. After depleting their fuel, they become red supergiants, and their cores collapse. This collapse triggers a massive explosion known as a supernova, releasing an enormous amount of energy. The leftover core can become either a neutron star or, if the remaining mass is sufficient, a black hole. Supernovae and black holes. A supernova is one of the most powerful explosions in the universe, occurring when a massive star reaches the end of its life. Its brightness can outshine an entire galaxy for a short time. If the core left after the supernova is dense enough, it collapses into a black hole. A black hole has such strong gravity that not even light can escape it. Black holes remain some of the most mysterious and least understood objects in the cosmos. The sun and stars are among the most fascinating objects in our universe. The sun constantly provides us with energy through nuclear fusion, while stars go through an entire life cycle, from their birth in nebulae, through their long main sequence phase, to their dramatic death, sometimes resulting in the formation of black holes. If you enjoyed this video, don't forget to like and subscribe so you don't miss out on more exciting cosmic topics. Thank you for watching, and I'll see you in the next video.